Okay, we're going to try to make us a auto transformer here for a in-fed half-wave antenna. So what we've done is we cut us a piece of wire here. Get my tape measure. This is what you need. This is about, now this one's 19 inches long. It's going to come out too long, but that's better than too short. This one here is about 7 feet. This is 14 gauge enameled wire, magnet wire they sometimes call it. And let's see here, I have some information on where to get that. I got it from Amazon. I'll show you the picture of the spool of wire. This is Remington Industries 14SI 0.2 diameter, no, 14SI diameter and 20-foot length, and it was $10. Amazon Prime, got it in a couple of days. Yeah, you can get this stuff about anywhere, except for some reason I can't find it on Mouser. The cores are available from Mouser, and it's the cheapest place I can find. MouserElectronics.com. These cores are manufacturer part number. And let me see here if I can get that in the camera. It's not really coming into focus too well because of the light. Let me put my hand behind it so you can see the part number. Look at the manufacturer part number there, which is right here, 594-300-3801. Ferrite, that's the name of the company that makes them, and they are let's see, $4.26 a piece at Mouser. These are 240 type cores, and the mix is 43. Do not deviate from the mix. You can get by okay with a little bigger core, but don't mess with that 43 number there. That's important. So anyway, first thing to do is take those two pieces of wire, and we're just going to twist them together here like so and make us a braid. And this takes a little bit of time. I've had people tell me that this twisting needs to be done nice and tight, and that insulation on this wire is pretty good. You don't have to worry about it shorting out. And if you did worry about it, it wouldn't do any good anyway. So I'm pulling and twisting, and I just keep on till I get almost to the end. And whatever we don't need, we'll just cut it off. Almost there. It's not perfect, but it doesn't make any difference. I haven't tried building one of these without twisting it. Who knows, it may not make any difference. Now, I think that is probably going to do us right there. So, I'm going to take it out of the vise. Now, this end here, this is going to be ground, and it's going to go to the ground terminal of the SO239 connector and to our ground lug. Alright, this end is going to be the beginning of the secondary. This is going to be our secondary right here. That's what that 7 feet of wire is for. So here's our core. I took 3 of these things. They're $4 a piece. Don't worry about the $4. Just go ahead and get 3 of them. This can handle a couple of kW sideband very easily. And all I did was put a dab, about 4 dabs of super glue around it, put them together and let them set a while, and they're stuck together very well. So what we're going to do, I'll stick this through the core, and I'm going to bring it around to about the halfway point, right there. See, as so. All right, and we're going to go ahead and wrap this around again, this primary. Okay, and then we're going to stuff it up through the bottom like so, and bring it around, pull it good and tight, and then right there we go. Now that is 2 turns, and we'll count them like this. Now here's where we started, right here. We go around, and that's turn number 1, and then we go around again, and there's the end of turn number 2. I'll try to get this all on the camera the best I can here. So you start here, and every time you reach this point, that's a turn, and you go back around again, there's another turn. So that's the conclusion of the primary. And again, this is your ground. All this is left over, so we can trim this however we see fit. Okay, the other end here, this little job, this is going to go to the center pin of your coax connector, your SO239. That's where your power goes in, right there. Okay, now we're going to take this. We're going to build the secondary. We're just going to continue around here and back down through the middle. All right, 1. We'll go there. We're going to get about 7 turns out of this on this side of the core. And I'll do it again. And then again. See how easy this is? Really, you can't go wrong. Yeah, this is 14 gauge wire. It's not too bad. I tried 12 and it was just way too stiff. I didn't like it at all. I don't think it's necessary. Might even be able to get by with 16. Let's stick it through here again. And now when you count the turns for the secondary, remember that our secondary and primary are wrapped together, so we've got to count it all. So remember, this was our first turn right here. 1, start here, go around. That's 1, 2, 3, 4, 5. Let's do 2 more. 1. Right there. You got to kind of squeeze them in there as you go. Yeah, it's better to have them close to the core when you do this. If you want to take your time when you're doing it and do a little neater job, that's fine. But anyway, Alright, let's see what we got here. We got 1, 2, 3, 4, 5, 6, 7, and what we do here is come out the bottom. We don't go back around again, and we're going to go over across the bottom. See how I did this? Alright, so now I'm starting again. This counts as a turn. That cross across there was number 7 because it went down through the middle of the core. So we count that as a turn. Alright. Alright, there we go. So that's 7 turns, and we just went around again. There's 8. Nine. Number 10. Number 11. 12. Sloppy work there, Steve. 13. 'Okay. Now, the ones I've seen built stop right there, and they come up like this, and they go over to the antenna outputs. I've really got 13 turns here, and it seems to be inconsistent what I have found, and I can go ahead and put the last turn in and then come up here like this. Now that'll give me 14 turns, which is a 1:7 ratio. I've seen it both ways. But anyway, let's count them again. Here's the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I've got more than 14 turns doing it this way. So what people do is they kind of come up like this, and then about the halfway point or somewhere they'll bend it over and go out to the antenna port. Now again, that's kind of a sloppy job because I didn't take the time to smash all this wire in there, but I hope you can see. Let me turn the camera around here at a different angle. The light might be a little better. You see that crossover on the bottom? So let's see. Again, this is our ground. The short one here is our input right there. And way over here is our output. So we have a 2:14 or a 1:7 winding ratio, and what we do is we square the secondaries ratio. 7 squared is 49, so that's a 1:49 ratio. Well, the next thing you do is you can mount it in a box, and I just happen to have a copy of Lowe's little web page here. This is Lowe's.com. You probably have a Lowe's store nearby. If you don't, you can order it. You can get these anywhere. It's just a electrical junction box. It's waterproof. $6.98. So really, you've got probably $3 in the wire. You got 12, 20. You have less than $30 invested in this thing, and then you can get some. Get you an SO239 and drill a hole in the bottom. And by the way, what I use to drill a hole with, my drill press here. Let's see if I can show you. See that cone-shaped drill bit, and that makes a beautiful hole for an SO239 connector. And then for the bolts, let's see. Here's the inside of a My antenna. Just a bolt like this, and a nut on the other side, and then a wing nut. That'll work. There's your ground terminal. That's for lightning protection. And the capacitor is the last thing that you need. You need 100 picofarads, and it goes across the SO239, across the primary. Don't try to use it without it. You'll find that starting at about 20 meters, your SWR will be creeping up as you go up in frequency until you get to 10 meters. It'll be pretty rotten. 100 picofarads, and you need 6,000 volts. And you can buy these little discs on eBay. What he used here was 220s, 220 picofarad in series, and that gives you 110 picofarads. And each one is rated at 3,000, so putting them in series doubles your voltage rating to 6,000. Now, that's about it. If you have an antenna analyzer, what you can do is hook about a 3,000 ohm carbon resistor or a couple of 1500s in series, and just hook them up between the ground and your antenna output here, like so, and then feed your power in from your analyzer to the input. You can go ahead and put your SO239 on there if you want it to be easier. Try to keep your leads short, and just for testing you should be able to get an SWR less than 2 to 1 from 3.5 to 28 megahertz. If it doesn't satisfy you, you can add or take away a turn off the coil. The antenna is never going to be resistive, so it's hard to tell what you're going to end up with. But for the most part, your SWRs are going to be down below 2 to 1. 30 meters is not a resonant band. It's not a multiple of a half wave. However, the impedance on the end must be high enough, but it's still below 3 to 1 and quite usable on that band. You will have a little ground current, a little bit of loss there. 60 meters is totally out of the picture. You can't use 5 megahertz. It's not a multiple of any of these bands. So, one last look. Be sure that everybody can see what we've got here. Here's the bottom. Twist it around like this. Count the turns. There's our input. Just keep them as short as you can. There's the other side. Okay, there you go. Thanks for watching.